So, hello everyone, my name is Kritika Vinash and I am going to be talking about E1cb reactions today. So, E stands for elimination and 1 stands for unimolecular and CB stands for conjugate base. So, if we move on to the conditions that are required for this reaction to happen, it's basically a poor leaving group. So, poor leaving groups can be things like F, SME2, NR3, OH, or OR, or NH2. Now, you might notice that F is actually halogen, and halogens are generally good leaving groups. So, the reason why F is a bad leaving group is because of its small size. So, if you take something like iodine, which is like one of the biggest halogens, it can distribute its negative charge across a very large area, so it's going to have less charge density, which basically means it's more stable. So if you take something like F, it's super small, so it has to distribute the negative charge on a very small area, which is unstable as the charge density is going to be pretty high. So if we move on to the next condition that's required, it's basically an acidic hydrogen on the beta carbon atom. So the carbon atom which is directly attached to the leaving group is basically the alpha carbon atom, and the carbon atoms which are attached to the alpha carbon atoms are the beta carbon atoms. Now, what it means to have an acidic hydrogen is basically if a base shows up like OH minus and it takes the hydrogen, it's basically gonna donate these bonded electrons to the beta carbon atom, which is going to result in a negative charge on the beta carbon atoms. So for the stability, we have to find it by checking the resonance and the inductive effects. So as you can see here, this is a 2 degree beta carbon atom and this is a 1 degree beta carbon atom. Negative charge is actually more stable on lower degree carbon atoms, therefore this is the more stable negative charge. So this is going to result in the major product. So now if we move on to the next condition, it's basically a strong base, which can basically be things like OH minus or a tert butoxide ion or RO minus. So if we move on to the next part, it's the rate. The rate actually depends on both Rx and base. So therefore the order is 2 as it depends on 2 molecules. But the molecularity is actually 1 as the conjugate base is the only molecule that is involved in the rate determining step. So if we move on to the mechanism, as you can see here, F is present and F is actually a bad leaving group as I explained before. So these two are going to be the beta carbon atoms and this is the base. So this base is going to take either this hydrogen or this hydrogen, resulting in a negative charge forming either here or here. Now as I previously mentioned, this is 1 degree, therefore it's going to be more stable, and this is going to result in a conjugate base with a negative charge over here. Now the reason why this is a unimolecular reaction is because this is the only atom or molecule, as you can see, that is being involved in the rate determining step. Now what the rate determining step is basically the process where fluorine takes its bonding electrons and then it leaves. Now this results in an alkene formation. Now as you can see, the alkene formed here is the least substituted alkene, therefore this is the Hofmann product, which is going to be major. Now the Zaitsev product will also form, but it's gonna be a minor product. Now as you can see, the reason why this is the rate determining step and this isn't is because this is actually an acid base reaction. As you can see, this hydrogen is going and attaching to this OH minus. So acid base reactions are generally very fast reactions, so they are not usually the rate determining reactions. So if we move on to example reactions, as you can see here, OH is the bad leaving group and NH2 is our base. So as you can see, this is a beta carbon atom and this is a beta carbon atom. So a negative charge can form either here or here. Now you might first look at it and see that this is a 3 degree carbon atom, therefore you might think that this negative charge is going to be the least stable, but actually as you can see here, there is resonance due to this double bond O and this double bond O, therefore this is going to be the most stable and this is going to be the least stable. Therefore a negative charge is going to form here and this is going to result in a major major alkene as this one, where the alkene forms here. Now if we move on to the next example, this is a beta carbon atom, this is a beta carbon, this is the alpha, and this is the leaving group. So as you can see, we have a phenyl attached to this beta carbon, which is going to result in resonance if negative charge shows up on this carbon atom, and therefore this is going to be the most stable negative charge. So the negative charge is going to form here, which is going to result in an alkene formation over here like this. Now if you check out the next example, it's basically NO2 on either sides with OCH3 as the poor leaving group. So now negative charge can either form here, as this is a beta carbon atom and this is a beta carbon atom, but negative charge is going to be more stable here due to resonance because of NO2, like the previous cases. So negative charge is going to form here, and then it's going to result in an alkene like this. So if we move on to this example reaction, this can be a beta carbon atom, this is an alpha, and then there's an alpha here, and then this is a beta. Now these two are not really attached to any carbon atom, so they won't be involved in the acid base reaction. So we can either remove the hydrogen from here, resulting in a negative charge over here, or we can remove the hydrogen from here, resulting in a negative charge over here. Now if you notice, this is a 2 degree and this is a 1 degree carbon atom, so this is actually going to be the more stable negative charge. Therefore nitrogen will take its bonded electrons and then it leaves. So basically nitrogen here actually has a positive charge, as it has 4 bonds. So if it takes this electron, it's going to become neutral. So basically our base here is actually moist Ag2, as Ag2O, when it's moist, it can provide OH minus ions. So as you can see, the positive charge on the nitrogen gets neutralized and this forms, and then an alkene is formed. So this is basically E1cb reactions. Thank you for watching my short presentation on E1cb reactions. Thank you for watching. Bye.